So sometimes it's necessary to convert a measurement from one set of units to another, just like I said. We'll keep it conceptually easy. I'm not dumbing it down, but it's easier to understand a concept when you make sure you get it if it's something relatable, right? So converting $2.73 from dollars to cents, right? How do we do this? And I know many of you taken chemistry, so you know how to do stoichiometry and all this, but we're, again, not going to leave anybody behind. Make sure we get it all in the same boat. So first, we find the equality that relates the two, right? So we're looking at dollars and cents. We all know that $1 is equal to 100 cents. So that's our equation of conversion, our conversion factor, which we then want to write as a form of a ratio, as a fraction. Right? So we have two choices, $1 over 100 cents or 100 cents over $1. Right? Which one we use? Well, what do we look at, again, we want to be goal-oriented. What are we trying to get? We're trying to end up with cents. Right? So we want something that is blank number of cents on top. Right? Anything over 1 is just, it's on top, but it's still itself. Right? So we want cents on top. We started off with something that's in dollars. And we know if we multiply something on top and bottom, they can cancel out. So $2.73 times 100 cents over dollar, the $2 will cancel because you're dividing dollars by dollars, and you're left with cents. Right? If I had asked you to convert from cents to dollars, you would have used the other ratio. Okay? So let's work through something like, let's convert 100 kilometers per hour to meters per second. So what I'm going to try and do is when I start to get to more involved problems, I will take a break and do it on the board, right? Because I think that tends to slow me down. I already have tried to help by bringing things up one at a time, but I find even that goes a little too fast for a lot of people. So sometimes if we have the time, we'll work out some problems on the board. But even then, there's already a slide in my slide book, and then I'll bring it up after we're done, right? So you don't, even when I'm doing stuff on the chalkboard, you don't have to scribble like crazy because it'll eventually all pop up over here on in your podcast and on your downloadable slides. For today, because most of these are pretty simple, let's go ahead and do these on the slide projector. So we have our equality equation, right? 1 kilometer equals 1,000 meters. So we can write that two ways. But we know that we're trying to convert two things at once now, right? We're not just going to convert from kilometers per hour to meters per hour. We want to meters per second, right? And obviously, we can do this in two completely separate steps, but that's kind of a waste of paper. What we're going to do is write down the second conversion factor. 1 hour is equal to 3,600 seconds. And that gives us these two ratios to choose from. Okay, so we start with our starting units of 100 kilometers per hour. And we know that we're trying to get rid of kilometers and replace it with meters. Right, so we want meters on top and kilometers on bottom so that this kilometer will cancel that kilometer. And we're left with meters on top. Right? And that would, if we stop there, we'd have meters per hour. But we know we want to get rid of the hour. So we're going to put an hour on top and the 3,600 seconds on the bottom. And when we do that, we finally end up with meters per second. Okay, so 100 kilometers per hour ends up being 27.8 meters per second. If you want to get a little more practice, go and verify that what I did here, where I said 100 kilometers per hour is about 62 miles per hour. Right. And this is the reason I put this on here is one, you now have the answer to a ready-made problem for you to go and test your ability on, right? Go make sure you can get this. Okay, so let's do one more example. Convert 4.5 grams per centimeter cubed to units of kilograms per meter cubed. Right? And I'm going to walk through this purposely slowly because I see some of you are actually taking notes, and if you can, try and stay ahead of me. Right? Because, like I said, you can't learn tennis by watching somebody play tennis. You got to get the practice. So we know that 1 kilogram is 1,000 grams, and we know we can write it in these two ways. Remember, our goal is to go from grams per centimeter cubed to kilograms per meter cubed. So we have one that converts from kilograms to grams, or vice versa. And we want to convert from centimeters to meters. So 1 meter is 100 centimeters. So we write these two ways. And now we apply it. So the grams is easy. It's just like last time, 4.5 grams. Get rid of the grams by putting it on the bottom. So we're choosing this one. Kilograms comes up top. That's what we were looking for. Great. But we have centimeters cubed. I only gave you something for centimeters, right? But centimeters cubed is just centimeters times centimeters times centimeters, right? So we're just going to apply, so I'm sorry, the grams canceled out. So now I'm just going to apply the this conversion factor that has the centimeters on top, so it has a chance of canceling these centimeter cubes. Apply it 3 times, right? So this centimeter times this centimeter times this centimeter cancels out that centimeter cubed. And then I'm left with meters, meters, meters. So it's kilograms per meters cubed. All those cancels except for those. And I have 4.5 times my 1 times my 100 times my 100 times my 100 divided by the 1,000 here. And I didn't bother writing all the ones out. Okay? So that's from start to finish how you do even more complex conversions.